So homework from yesterday. Identify population parameter sample statistic. For number 2, the population is very straightforward here.
How is Little lost on this one?
What is your population?
All individuals in U.S. households.
Just all U.S. households, because those are the ones that were contacted. So what is the sample?
U.S. household survey December 2000.
I would probably do something by
What's the 55,000 number? Is that in December 2009?
yes. Wait, yes. But that's why I don't include numbers or anything, because sometimes that gets confusing. And sometimes it makes you think you're describing something, but you're really not. We're only given one number here, which is the 10.0. Is that a parameter or a statistic? Because it's saying of those interviewed, so it's just these that were surveyed. So our statistic is what symbol? P hat, 10%, 0.1, whichever way you want to call it.
Is it a probability because it's a percentage?
Essentially, yes. Number 3. So this one is tricky but it's not supposed to be. What is our sample here? One where he's cooking a large turkey for a holiday meal. He wants to be sure that the turkey's safe to eat, which requires a minimum internal temperature of 165. Use a thermometer to measure the temperature of a turkey at 4 randomly chosen spots. So what is our sample? The 4 places. Now, that wasn't direct wording, so person to person, that's going to be worded a little bit different, but essentially you're saying the same thing. It's the places that he actually took. I don't need the 4 there. But it's the ones where he actually used the thermometer to take the temperature. So backing up from there, that makes the population what? And you can say the entire turkey breast, anywhere on the turkey, all possible places where he could have taken the temperature, but it's of that turkey. Wording again there is going to be a little different person to person, but it's essentially saying anywhere in the entire turkey that I could have done this. So this gives me 2 different numbers. It gives me 165 and 170. Well, this one is very obvious and says of the sample. Well, this is a what kind of statistic? Like, it's not a mean, but it's a what? It's just a minimum. So all we could write for this one, we don't have a symbol for that. I don't feel like searching for them. I guess it's not that hard. So then up here, my parameter would be what? Mm-hmm. Equals what? So even though that's not one of the typical symbols we use, that's still a statistic, and that's fine. We just don't have a symbol for minimum. We just call it min. Questions on that one? I think that one was one of the ones that was the trickiest, but not intentionally. It's just kind of the wording of the problem. All right, so for these, I'm answering it like, no, these, it doesn't ask you for the population and the sample, but I want to say what the population sample are. So number 6, Florida has played a key role in recent presidential elections. Voter registration records show that 41% of Florida voters are registered as Democrats. To test a random digit dialing service, you use it to call 250 randomly chosen residential telephones in Florida. If the registered voters contacted, 33% are registered Democrats. What would be our population here? Registered voters in Florida. What would be our sample? Registered voters that were contacted or chosen using the random digit dialing service. That was not part of the question, but just talking through it. So my two numbers are here and here. So all I have to do is figure out, hey, which one described the sample and which one described the population. So my parameter is which one? 41%. It's of Florida voters. And what is my symbol there? What equals 41%? And is 41.41 the same thing as percent? Yes. So I would write statistic and write what? Equals 33%. So in number 8, a random sample of female college students has a height of 64.5 inches, which is greater than the 63-inch mean height of all American women. What would our population be?
Female students in college.
Our population would be all adult American women. So then what is our sample?
Women in college.
It'd be the female college students that were selected. This is kind of one of those where it's not randomly selected from the entire population, but we're doing it to be able to compare. So our parameter would be what symbol? Mu. And mu equals what here? 63 inches. And our statistic would be what symbol? X bar equals 64.5 inches. So remember, I've already told you I'm going to ask questions on the test that look like this. And they said, what's the population? What's the sample? What's the parameter? What's the statistic? This is a good example of one that could have had multiples. So it would have been something like is greater than the 63-inch mean with 3-inch standard deviation. And I put that in right there. Then I would add a second one here, which would be what? Sigma equals 3 inches. So I can have multiples like that, especially in a situation where it's mean and standard deviation, because those kind of go together. Number 9, this is the one of a school newspaper article claims that 60% of students at a large...
I just remembered I have to be in the oxygen.
Yeah, go ahead. Students at a large high school did all their assigned homework last week. Some skeptical AP Stat students wanted to investigate whether this claim is true. So this is kind of one where I was talking about yesterday, where hypothetically we go with the claim and then we see if it's right or not, like the 80% free throw shooter thing. So we went with the claim that it's 60%. We used a simulation to create dots for that. This is what the dots gave us. So is this a sampling distribution of p hat? This is the whole point of yesterday. Is this a sampling distribution? Why? It's an approximation. Because why? Of each dot represented 250 students. Oh, wait, no, 100. There are 250 of them, but there were 100. So this was an approximation because they did not actually have a dot for all possible samples of 100 students from the school. So that would be a whole lot more than 250. I described the distribution. I talked about we want to do this generally. Where's about the center? Where's the center? 60-ish. It might look a little bit lower, but these high ones right here might pull it back, so it's probably about 60. Having a spread down to about 50, definitely to 50 and 70, I'd kind of call that relatively high spread. Because if I'm trying to aim to see if it's actually 60, that gives me a range of 20% to spread across. That kind of seems like a high spread relatively. And then what about outliers? Some people are going to say yes, some people are going to say no. If you say yes, you have to say what? Appears to be. Some people are going to say these appear to be possible outliers. These might appear to be possible outliers, but you cannot definitively say yes or no because we did not calculate. And then part C says so this is what the distribution should look like if random samples were taken. Does everybody understand that? So now they're actually going to go take just one sample and see where that dot compares to that whole distribution of dots. So this 45 out of 100 would end up right here. Where does that fall in that distribution? There wasn't a single dot that was that low. So does it seem realistic to actually get a value that low if the population was 60%? No. So maybe what's the actual case here? It's back to the free throw thing that I was talking about. So we're kind of skeptical here. So maybe, or that 60% really isn't right. So maybe the claim that they said about 60% of students completing their homework wasn't really right if our value actually got us the value way down here. Does that make sense? So we are comparing that dot to the distribution of dots. And that was the end tie-in that that's our lead into today. So then here, again, is the sampling distribution of X bar? No, because it is not all possible samples of 20 girls taken from the 300 at the school. The center here is about what? 64. What's the shape of this one? Fairly bell-shaped, definitely symmetrical. This one, it's a little funny, but it's still overall relatively bell-shaped.
And how do we know that they didn't use all of the possible?
Because there would be
Like, how do we find that though? Like,
you don't need to come up with that number, but if you do the 300 NCR 20, it ends up giving me a number that has 30 zeros behind your first number.
okay.
You don't have to do that, but that's where that's technically coming from. Unless this thing, this is the whole point of yesterday. It's almost never going to be the actual sampling distribution.
Okay.
So center about 64, bell-shaped. Suppose the girls average, they actually sample 20 girls, and their actual average height was 64.7. So that would fall about right here. No, further over. About right here. Does that seem unreasonable?
It doesn't really match up.
So if they have one dot that's like right here, does that look like it wouldn't fit in this distribution? Because here, did this one dot look like it wouldn't fit in this distribution? Yes. as opposed to here, that looks like it would have fit in that distribution. So that's not telling us, hey, something's wrong. I can't even see that. Hey, something's wrong. Their claim is bad. I counted dots and I counted up to about 27 or so that are over here. Well, the problem tells us that there's 250 dots. 27 out of 250 gives us a little over 10%. So there are about 10% of the dots that were that far away on that side. So that doesn't seem unreasonable that we would get a dot there. Questions about that? Because that is a major concept tying into today. All right, number 19. So this arrow at the bottom is where the population parameter is. So does the data match that center or not? This first one, A, is it biased or not biased? Biased. B, not biased. B, C. That's still going to balance about there, right? It's still pretty unbiased. What about D? So the unbiased ones would be these two. What else do we look at other than just bias to see if it does a good job? Variability. Well, this one has a what kind of variability? This one has a. So we want low variability and unbiased. So B is the best job of doing that. Obviously an old book here talking about Donald Trump as a business tycoon. Newspaper poll reported that 73% of respondents, so this is a what? 73% is a statistic. It's a number that describes that sample. 22, I don't love 22. The name for the pattern of values that statistics takes when we sample repeatedly from the sample population, from the same population, it's best described as E, but it's usually an approximation. And that's why I don't love it, because we're attempting to get that, but it is an approximation of, but it should be E. '23, as of yesterday, you should be able to answer this question, but after today, you definitely shouldn't get it wrong. One thing that we wrote in the notes yesterday is the variability is most explained by or most affected by what? What? Our sample size. Well, our sample size initially here was what? Does our sample size change? So it actually doesn't matter the fact that this changes, which means it's about the same because I didn't change that sample size. And I'll give you a better justification of that today of why that is true. But just based off of that one thing that we filled in yesterday, you should be able to answer that. And then the last one, increasing the sample size. So I kind of hinted at increasing sample size is always going to help things. So reduce bias, reduce variability, reduce effect of non-response, reduce variability of opinions. Am I going to reduce the effect of non-response if I take more? Because if 10% aren't going to respond, 10% still aren't going to respond, right? If I take more, am I going to change their opinions? No. So those aren't right. Am I going to change where the center of it is if I take more? No. Am I going to change how much it's spread out if I take more? Yes. So we are reducing the variability. So basically back to this one, to go from here to here could possibly be taking larger sample sizes. Questions on any of the homework?